Today we're talking about relations and functions. Some of this should be a review from Algebra 1. We'll see if you remember. Okay, relation. A relation is a set of ordered pairs. So, for instance, you have x comma y. That is a relation, okay? Sometimes you'll have like multiple x, y values. Remember that your domain is always the x coordinate of the ordered pairs, or we'll talk about whatever x values it can be, and the range is your y coordinate, or whatever y values could be in the problem. A function is a relation where the domain is paired with exactly the domain, meaning the x value, is paired with exactly one element of the range. F of x instead of y denotes the equation is a function. But we can interchange f of x and y. Just know that that's what function means. So basically, if you're looking at a set of ordered pairs, your x value can only match with one y value. If you see the x written twice, then it's probably not going to be a function. Okay? So this says state the domain and range of the function of the relation, and is it a function? So your domain is your x values. What are my x values here?
Minus 4.
5 and 5.
Negative 4.
Minus 3.
Negative 3.
Minus 2.
Negative 2.
Plus
And 2. Did any x value repeat? Like, did we have the same x value twice?
No. No, it's negative and 1.
No, so you can have a negative and a positive. Those are different numbers. So right now we would know that this is a function. Okay, if your x's repeat, then it wouldn't be a function. Okay, what are my range values?
5 and 5.
Good, so we're going to all of our y's. So we have 5,
Minus 4.
negative 4,
0.
0,
Minus 4.
and then I have negative 4 again. Do you think I need to write that twice?
No.
No. Basically, if it's written once, that's all you need to do. If it comes up again, you don't have to write it again. Your range can repeat. Okay? But your domain should not. So the answer is yes, this is a function. Okay. So the x values cannot repeat.
Make it a function.
Right. All right, so here we have B. They're matching domains to range values. So what is my domain on this problem? Yes.
How would it, if it was a non-function, how would it be non-function?
Like there would have been an extra, like they would have had another ordered pair that was like, let's say negative 4 comma 6. Like if you had all these, see, then you would have 2 negative 4s, 2 x values that match, and it wouldn't be a function. Okay? All right, so our domain on this one is 1, 4, 6. And my range is what? Negative 9 and 3. Okay, now, so if you were to write these like as ordered pairs, this would be like 1 comma negative 9, 4 comma 3, and 6 comma 3. Did any of the x values repeat?
No.
No. So is B a function? Yes. Okay. On this next one over here, what is my domain?
7, 2, and negative 4.
7, 2, and negative 4 is correct. And then my range is what?
Negative
3,
3.
3,
6.
6,
8.
and 8. Now, let's say there was a number in here, but there wasn't a line going to it. Would that be part of the range?
No.
No. Okay, so if we look at this one, all the ordered pairs, we have 7, negative 3. We have 2, 3. We have 2, 6. And then we have negative 4, 8. Is this one a function?
No.
No, because if you see here, the same x value is used twice. So no, it is not a function. All right, on these next problems, you might want to graph some of them, or maybe by looking at them, you'll know what kind of graph it makes. And that will help you determine whether it is a function or not. But actually, I'd like to skip this and we're going to talk about the vertical line test, and then I'm going to come back to this, okay? So move to the next page, and we're going to come back. Okay, do you guys remember the vertical line test? Okay, so half of you. The vertical line test is used to determine if a graph is a function, okay? So basically, the vertical line test is if you were to like label all these ordered pairs, like for instance, let's see here, 1, 2, 3, 4, wait. 5, thank you. I'm like, my eyes are not working. So that's -5, -3. And then we have -2 and 0. And then I have 0, -2. And I have 2, 2. Notice that none of the x values repeat, correct? Okay, so right now, is this a function?
No.
Yes, because none of the x values repeat.
Oh, I know what it is if the line touches two places at once, it's not a function.
Right, so I'm going to just throw another point on here, okay? And let's just say my point is right here.
No.
What ordered pair is that right there?
2, 2.
-2, -2. Do you notice here how -2, 0 and -2, how those have the same x values? Yes or no? Yes, we notice that? So that would make it not a function. And if you were to draw a vertical line, it would end up hitting 2 points at one time. So the vertical line test is if you can draw vertical lines and it only hits 1 point at a time, it's a function. But if it ends up hitting 2 points, then it's not a function. Does that make sense? Okay, so, and this wasn't part of our thing, and this one was, yes, it's a function, but when I added in the red, then it wasn't a function. So if you look at B here, is that a function, yes or no? No, because if you were to do a vertical line test, it would hit 2 points at one time, wouldn't it? Okay, so B is no, it is not a function. What about C? Do you think C is a function? Yes, because these are actually like curving, and so if you were to do vertical line test, it would only hit 1 point on the graph at a time. What about D? No, because again, if you were to draw a line, see how I draw a vertical line that's going to hit 2 points there? So this one is no. And then what about E? No, because again, right here, at any point, if it would hit 2 points on a vertical line, it is not a function. Okay? Now let's go backwards, back to here. Okay, so it says determine whether each represents a function. Okay, anytime you have a y and an x in a problem and they're just y's, just x's, this is going to end up making what type of graph? A line, okay? If I were to graph this, you know, you'd go up 2, make a point, and then you'd go like up 10 over 1. This is a line. Do you think it'll pass the vertical line test?
Yes.
Yes, so is this a function?
No. Yes.
Yes, because it would only hit 1 point at a time on this line, okay? If you were to draw little vertical lines. So the answer is yes, this is a function. Anytime you have a line where you have your y and x like this, a line will always be a function unless it's like y, no, not y equals, x equals, and then it'd be a vertical line and it'd hit a whole bunch of points and that one wouldn't work. Does that make sense? So all other lines will be a function. So anytime you just have x and y in a problem, it's a line, and the answer is yes, it's a function. What kind of graph will this one make? It's a what? Parabola. So if I were to graph this one here, it's going to make some kind of parabola, okay? Like that. Does that pass the vertical line test? Yes. Because even though these lines are kind of like going up, they're really actually slanted, right? And they're going to keep kind of going out. Remember how we talked about that? So the answer is yes, this is a function because it wouldn't hit 2 points at one time. Do you guys know what kind of graph this makes? Okay, whenever you have two squared terms, it's going to make some type of circle or ellipse but, or oval, okay? So anytime you have like a circle or an oval or anything like that, do you think it's gonna be a function? No, because again, if you did your vertical line test, it would hit 2 points. So this is no. Okay, and this, notice we have x and y, but we have the square root. Okay, so you know how when you have a squared, it makes this U-shaped graph? Yes? When you have a square root, it makes a sideways graph, but actually it's only half of a parabola. So is this one going to be a function? Yes. Because with the square root, we're not going to have a negative side, are we? Because if we ended up with a negative, it would end up making a what? An imaginary number. Okay. All right. Are we okay with vertical lines? Vertical line tests, functions? Okay. All right. Now we are going to talk about evaluating functions. Okay? If you notice here at the top, they are telling you that f of x equals 3x plus 5 and g of x equals 2x squared minus 7. Okay. Yes, that's all you're doing. Okay? This is not very complex. All we're going to do is substitute numbers in. For instance, this says f of negative 6. Do you think I'm going to go to the f equation or the g equation? You guys are pretty smart, some of you. We're going to go to the f equation. This side is just telling you which equation it is. This is saying this is the f equation. And they're saying that wherever you see x, instead of writing x, I'm going to write what? Negative 6. So don't worry about this side. The 3x plus 5 is the only thing that matters to me. And within that, so I'm going to write 3x plus 5. Okay? But instead of writing x now, I'm going to write what?
Negative 6.
Thank you, negative 6. So 3 times negative 6 plus 5, and we're going to simplify to get our answer.
Negative 13.
Good. We get 3 times negative 6, which is negative 18. And then negative 18 plus 5 does make negative 13.
That's your answer.
And that is your answer. So f of negative 6 is negative 13. You plug, so basically this is just telling you this is the f equation. So you're not worrying about this side. The only thing that means anything to you is 3x plus 5, which is what I wrote down. And then you're just substituting in negative 6 for x. So yeah, so now we're going to the next one. So B. B says f of x plus 1. So now they're telling us we are going to plug in x plus 1 wherever we see x in this problem. So again, I'm going to write down 3x plus 5 because that's my f equation. But this time instead of x, what am I going to plug in? X plus 1. So that means, so I'm taking this right here and I'm plugging it in for x. So I'm going to write this as 3 times x plus 1 plus 5. And this one we are only going to be able to simplify, right? So we are going to distribute the 3. No. So instead of, just like how here, instead of writing x, I wrote negative 6 in, right? There was no more x's in the problem. Oh, okay. Okay, good. All right, so on this one, instead of writing x, I'm writing x plus 1. So we distribute, and then I saw plus 5 at the end, and then you can simplify. We can add together the 3 and the 5, right? And so my answer is 3x plus 8. Do we have questions there? Isaiah, are you doing this with us? Okay. Okay, so now we have f of y. So again, we have the equation, which is 3x plus 5. But instead of writing x this time, what am I going to write?
Y.
So that means my answer will just be 3y plus 5 because there's nothing more I can simplify. Chris, are you getting all this stuff down?
Yep.
Please sit up. Where's your pencil? Okay. G of negative 4. So this time, notice we are going to which equation? The G. So I'm going to write down 2x squared minus 7. But again, instead of writing x, I'm going to end up writing what? Negative 4. So I have 2 times negative 4 squared minus 7. What will I do first in this problem?
2 times 16.
No. Oh, first I'm going to do negative 4, right?
Yeah.
Negative 4 squared is
16. That's
16.
what I said.
So now we have 2 times 16 minus 7, and 2 times 16 is
58.
32. And 32 minus 7 is
54.
25. Okay.
I'm still off.
A little bit, yeah.
I think it was you guys.
Okay. Do we have questions? Does this like make sense?
No. That's not what I said.
Can we do the rest first?
Yes. Okay, we're going to do the next one together. Okay, so again, we have g of 2y. So my equation is 2x squared minus 7, and this time I'm taking 2y and plugging it in for x. So that means I have 2, because I have the first 2 that's in front, right? Instead of writing x, I'm writing 2y. So I'm going to put that in parentheses. I have 2y, and then it's being squared minus 7. So just be careful that you're writing everything that you need to. What happens when you have 2y squared? That will end up becoming 4y squared. Good. So that means I'm going to have 2 times 4y squared minus 7. Because we square the 2 and we also square the y. And then what is 2 times 4y squared?
8y squared.
Good. 8y squared minus 7. And that's as far as I can go there. All right, E. What am I going to do for E? Again, we're going to use our which equation? G equation, which is 2x squared minus 7. But this time I'm going to plug in x plus 1. So that means I have 2 times x plus 1 squared minus 7. What will I do first on this problem? Good. We have to do the box for x plus 1. Okay, so remember whenever you have something like a variable and a number being added and it's being squared, you have to do your box or FOIL method. So we get x squared, 1x, and 1. So, and don't forget that, so this is going to end up being 2 times x squared plus 2x plus 1, close your parenthesis, and then you solve minus 7. Okay, then next what will I do? Distribute the 2. So that means we're going to distribute that through. We get 2x squared plus 4x plus 2, and then I solve minus 7.
And you subtract the 7.
Good, and then you can combine those like terms, exactly. So we end up getting 2x squared plus 4x minus 5. And that's your simplified answer. What do you think we're going to do on F? Right. You're going to do these as like 2 separate problems.
And then add them together.
And then you're going to add them together. Exactly. So I'm going to give you a minute to try F on your own. And once you get your answers, you can write them on your whiteboard or raise your hand. Yeah, when you get your answers, go ahead and show me. You might need to maybe carry your bag for her. I don't know what's going on.
She said she was gonna faint.
Oh, that's what she felt like? Yeah, so maybe. I felt like maybe she walked out and I just didn't see her. Good. No, Marcus. Yes, you have it.
Is that it? Is it 22?
Yes. Okay, so the correct answer for F is 22. So let me just go through that. Okay, so for F of 2, I'm going to do my two separate problems. My equation was 3x plus 5. Okay, so that means I have 3 times 2 plus 5. 3 times 2 is 6, and 6 plus 5 makes 11. Okay, so then now I'm going to go over here and I'm going to do my G equation. Well, my G equation is 2x squared minus 7. So there, McKenna, I need you to sit up. We have 2 times 3 squared minus 7. 2 times 9 minus 7. And we get 18 minus 7, which also equals 11. And then we have 11 plus 11, which makes 22. And that is the correct answer. Okay, I'm going to give you, do you guys want to try G on your own? Did you already try G? Okay, I have the answer as 28. Did anybody get 28? That's what I thought. Okay, so let's go through it. So my F equation is what?
Oh, 24 plus 5.
3x plus 5. You need to be doing this with us, okay? Okay, so I'm plugging in 8. Shh. 3 times 8 plus 5. 3 times 8 is 24, and 24 plus 5 is?
29.
Okay, 29. Now I'm going to do G of negative 2. Okay, so we have 2x squared minus 7. So that's 2 times negative 2 squared minus 7. Negative 2 squared is what?
Negative 4.
Nope.
4.
Positive 4. 2 times 4 is?
8.
Clean your hands. 8. And 8 minus 7 is?
1.
1. And then what is in between here? A subtraction sign. Okay? So don't forget to pay attention to what's there. And if this had been a negative number, then you would have had 2 negatives make a positive. But 29 minus 1 makes 28. Okay, so those of you that did not get the answer, are we good? Or not? Okay.
Or you wish you were.
H. Okay, so F of 2x. Do you guys want a minute to try this one? Or no? Should we just do it together?
Yeah, just do it together. It's so tricky.
Okay, 3x plus 5. Instead of writing x, what am I going to write? 2x. So 3 times 2x plus 5. 3 times 2x is?
6x plus 5.
6x plus 5. And I can't simplify that, right?
No.
So we just have 6x plus 5. Okay, g of x. No. G of x, we have 2x squared minus 7, and I'm substituting in x for x, so is anything going to change there?
No.
Okay, so that means I have plus 2x squared minus 7. So whenever we write answers, we should write them in descending order. So I'm going to start with?
Plus 6x minus 2.
Perfect. 2x squared plus 6x, and then 5 and negative 7 make negative 2. Thank you.
And I'm writing this now.
All right. Do we feel pretty good about this?
Yes.
Awesome. Okay. Example 4, it says state the domain of the function. We talked a little bit about this on worksheet 3B.
It's 2.
Okay. The one thing you have to worry about with domains is that you do not want them to make imaginary numbers. Okay? So you do not want imaginary numbers. So I'm just going to write this here. No imaginary numbers. How do you spell imaginary?
IMAGNRY.
Okay, got it. No imaginary numbers. And also, no zeros in the denominator. Why can't you have a 0 in the denominator?
You spelled denominator.
If you had 0 in the denominator, it actually makes it what?
0.
No, it makes a 0 with a line through it.
Yeah, it makes it undefined.
Yeah.
Okay, a 0 in the denominator makes it undefined.
Under is undefined.
Under is undefined. If you have a 0 on top, it's okay. It'll just make 0, but a 0 under is undefined. Okay, so when you're looking at these are the only things you have to think about. So, is there any way of getting an imaginary number here? No, because there's no root, there's no even root that you would end up pulling out a number and getting an imaginary number. Is there a fraction here?
No.
So is there any way of getting 0 in the denominator?
No.
No. So therefore, what is your answer going to be for A?
Real.
All reals. Exactly. Your domain is all reals. Or just the little r thing is fine. Sorry. Okay. What about B? Okay, you have a root, right? You have an even root. Can we end up getting a negative number under the root that would make an imaginary number?
Yes.
Yes. Is 0 under a root okay?
Yes.
Yes. 0 under the root is okay. So, at what values will start making this imaginary numbers?
-1.
Bigger than 1, right? So, if you just take what's under the root and set it equal to 0, so x minus 1 equals 0, because it can equal that, and we add 1 to both sides, we get x equals 1. So at 1, it gives a 0, which is fine, and anything that's smaller than 1 will end up giving it a what? A negative number. So your domain here means that your x has to be greater than or equal to 1. Because anything that is smaller than 1 will give you a negative number under your root. Okay, what do you think about C? It won't cancel out because one's a plus and one's a minus.
Wait, it will or won't?
It will not. This doesn't cancel out. They have to be exactly the same to cancel out. What's the only thing I have to worry about on this problem?
Oh, the x on the bottom.
The x on the bottom. What value for x would make a 0 in the denominator?
An x.
A positive 2. And if you want to, what you want to do is set your denominator equal to 0 to see what value it would make. So if you go x minus 2 equals 0, the only value that would make a 0 in the denominator is what? 2. So that means for this domain, it is all reals except x cannot equal 2.
This is complicated.
So any number for this will work except for 2. 2 is the only number that will not work. Okay, so what about D? What should I do for D? Yeah, set your denominator equal to 0. And when we do that, we get 2x equals 8, because you'd add 8 to both sides. Divide by 2. X equals 4. So what would this one be?
All real except for 4.
Exactly. All reals except x cannot equal 4. I kind of want to give you one more problem real quick.
Okay.
Oh my goodness, be
I
quiet.
like it.
Okay, so E. Let's say you have this. X plus 2 over 5. What would that domain be?
Undefined.
Is there any value that I could plug in for x that will end up making this denominator 0? No, because there's a 5 in the denominator, right? There isn't a variable in the denominator. So this one's just all reals. Are we all okay with that? Because nothing will change the denominator. The denominator will be 5. Okay? All right, we are done.